Now that we learned about stoichiometry and the ideal gas law, it is time to combine these two concepts together. Let's look at two examples of volume of gas problems. My first question, what volume of chlorine gas at 38 degrees and 1.63 atms is needed to react completely with 10.4 grams of sodium to form sodium chloride? The first thing we need to do on any problem is we need to write and balance the chemical equation. I've already written it for you, but let's pull it apart. It says chlorine gas is needed to react with sodium. So I have chlorine gas because it's a diatom reacting with sodium. And it says to form, which is my arrow, sodium chloride. It is important to pay attention to the states of matter. Sodium, a metal on our periodic table, is a solid, and sodium chloride, which is table salt, is a solid. Chlorine, which is a halogen and one of our diatoms, exists as a gas. Let's balance this reaction. We have 2 chlorines to 1 chlorine, so I need a coefficient of 2. I now have 2 sodiums, so I need a coefficient of 2 over here. And now my ratio becomes 2, 1, 2. Now let's go back and let's read for the rest of the information. It asked me to find the volume of chlorine gas at 38 degrees, which is my temperature, and this ATM measures my pressure. It tells me that I have 10.4 grams of sodium. So in order to solve my problem for volume, I'm going to have to use the PV equals nRT formula. Well, I don't have R in my list, but we know R is a constant value. So the letter we're missing is N, which represents the mole. So in order to find this mole, if we want to find the mole for chlorine, we have to start with the given value of sodium and convert it to moles of chlorine. We're going to take our given and move towards the question mark. According to stoichiometry, my grams of sodium will have to convert into moles of sodium. And then I can convert into anything that I want, and here I want the moles of chlorine gas. Remember when you go from grams to moles, the mole is set equal to 1? When I want the grams, I have to use the periodic table and transfer it into the mass. And now here I'm at the ratio mole to mole. So I look up chlorine and it has a coefficient of 1, and I have sodium, which has a coefficient of 2. I'm using my calculator. 10.4 divided by gives me 0.226 moles of chlorine. Now before we go into our perv nerd equation and we want to solve for V, because that's my question mark, remember you should always check your units to make sure that they are acceptable. Your pressure has to be in atms, your volume in liters, your moles in moles, and your temperature in Kelvin. So since I'm finding volume, my answer will have to be in liters. So my temperature here is 38 degrees Celsius. So I'm going to have to add 273 to this. And when I add 273, I'm going to get a value of 311 K. Now we know that my mole is okay. I've got my mole of 0.226 moles. I plug in my R value. My temperature value has now been converted to kelvins, and I'm going to divide by my pressure, which we know pressure has to be in atms, and it was given to me in atms. I can do my calculator work, and I get 3.54. Moles here is in the numerator, moles is in the denominator, they cancel. Kelvins in the numerator, kelvins in the denominator, they cancel. ATM is on top, ATM is on the bottom, and I'm left over with liters, which is what I should have gotten. So what volume of chlorine gas? 3.54 liters. Let's look at another example. How many liters of gaseous carbon monoxide collected over water at 27 degrees and 0.247 atms can be produced from the burning of 65.5 grams of carbon according to the following equation. So I have carbon monoxide being collected over water. So it's being collected, that means that's my product, CO. And it tells me it's being produced, so again, it's produced, so that's carbon monoxide. We're gonna burn carbon with oxygen gas. Oxygen is a diatom, it's a gas, okay? Carbon's a solid, carbon monoxide is a gas. Pay attention to those things. So since I have 2 oxygens, I need a coefficient of 2 to balance my oxygens. Now I have 2 carbons, so I need a coefficient of 2. So my ratio is 2, 1, 2. Let's pull out our information. Put this in here for you. When I read my problem, it asks me to find the liters of carbon monoxide gas. So I want to find the volume. It's collected over water. That means it's my cow problem. I'm at a temperature, and again, I'm at a pressure in ATMs. I'm going to burn 65.5 grams of carbon. I see over here that I'm working with my gas. Since I'm working with my gas, I can use the PV equals nRT formula about this guy. Again, I don't have R, but I know R is my constant value, and my N, I'm missing my N. So we are going to have to eventually figure out what my N is. So I'm going to take my temperature, I'm going to convert it to Kelvin. So 27 degrees plus 273 is 300 K. And because it was collected over water, this pressure that I was given is not the correct pressure. This is the pressure of the water and the gas. So I have to take the total pressure, the barometric pressure, and subtract the water pressure from it to get just the pressure of the gas. So in our textbook, we're going to go to page 899. We're going to look up the temperature of 27 degrees. Here's 27 degrees. It's 26.7 millimeters of mercury. So I have 26.7 millimeters of mercury, but I realize that my pressure that I was given is in ATMs, and these pressure units don't match. So I need to take this pressure of 26.7 millimeters of mercury, and I need to convert it to ATMs. So I know in 1 ATM, there's 760 millimeters of mercury. So with my calculator, 26.7 divided by 760 gives me 0.0351 ATMs. So now I can take the total pressure, which was 0.247 ATMs. I can subtract this little bit of pressure that I have from the water. I subtract that out, and I get 0.212 ATMs. So this is the pressure value that I need to use later on in my ideal gas law. Now I'm going to focus on finding my moles for my carbon monoxide, my N value. So I'm going to start with my given. I'm going to go to my question mark. Again, I'm going to start with my 65.5 grams of carbon and go to moles. I know that that is going to be a 2-step problem. So in 1 mole of carbon, I go to my periodic table. It has a mass of 12.01 grams. I'm now going to use my ratio. So my ratio of carbon monoxide is 2 to 2 to carbon. So we're in a 2 to 2 ratio. I do my math, and I get 5.45 moles. Now I have all my missing pieces. I'm going to solve for volume. I'm going to replace my N with my 5.45 moles, multiply it by R, which is my constant, multiply it by T, which we converted to 300 Kelvin, and we're going to divide by our new pressure of 0.212 ATMs. I'm going to check my units. My mole is on top, my mole is on the bottom, my Kelvin's on top, my Kelvin's on the bottom, My ATM's on top, my ATM's on the bottom, and I'm left with just liters, which is what I wanted. Now, a future problem might ask you to go to milliliters. This question just asked you how many liters. So this would be my answer of 634 liters. But if it was to ask you for your milliliters, you have to convert your liters to milliliters, and in 1 liter, there's 1,000 milliliters. So we would multiply this out, and we would get this very, very, very large number of milliliters.